Hello everyone. Today we're going to be going over some of the different angle relationships that angles can have with each other. These relationships depend on where the angles are located relative to one another, and knowing all the different relationships between angles can be really helpful when you're given only the measure of one angle and you're asked to find the measure of an angle with a line that makes up said angle. So, firstly, what's really important to know are the three kind of parent types of angle relationships. And we'll see these in more of the subdivisions of the relationships as well. So first is congruency. We see congruency when two lines intersect to make a pair of angles that are the same measure. So say this angle right here was 90 degrees. As these two intersecting lines form an opposite angle, it is going to be congruent to that 90-degree angle. So congruent means the same measure. All right, another type of angle relationship that two angles can have is called a complementary relationship. This happens when two angles, we'll call this angle A and this angle B, when their measures are added together, it equals 90 degrees. So if we knew that angle A and angle B were complementary, and we were given that the measure of angle A is 40 degrees, then with that information we could decipher that the measure of angle B is 50 degrees. As when we plug in 40 for the measure of A, and we need it to equal 90, B would have to equal 50 degrees. All right, the third type of angle relationship is one we're going to be seeing later in this video, called a supplementary relationship. This is when two angles add up to the measure of 180 degrees. When a horizontal line is cut down the middle or unevenly, it doesn't matter. The two angles it creates, we'll just look at these two angles on the top. They will be supplementary angles. So let's go ahead and call this angle C and this one D. As their base is a horizontal line and it is cut by another straight line, go ahead and make that straighter, we are able to infer that these two angles are supplementary. Not to infer, we're able to know for certain. So if we are given that the measure of angle D is 120 degrees, we can create an equation similar to that we did here for the complementary angle equation, where as these two angles are supplementary, their measures added together equal 180 degrees. So when we go ahead and plug in that the measure of angle D equals 120 degrees, we can then subtract 120 to learn that the measure of angle C is 60 degrees. All right, there are three important angle relationships that we will go ahead and continue learning about later. Now, we're going to take a look at another subdivision of angle relationships. These are very common when we are given two parallel lines, like you see here, and they're cut by a transversal. when a line is cut by a transversal, when a pair of lines is cut by a transversal, it creates both alternate and consecutive angles. Let's first take a look at some alternate angles. We have two groups of 4 angles. Here's group 1 and group 2. However, there are also different ways to group the angles. If they are on the same side as each other, say this angle and this angle, those are called consecutive. But when they're on opposite sides from one another, say this angle and this angle, it is called alternate. Alternate angles are on different sides of the transversal. I'll go ahead and make those more clear. Another example of alternate angles would be above the parallel line here and below it here. As they're on opposite sides of the transversal, that makes them alternate angles. Now, going back to the consecutive relationship, when angles are found on the same side of the transversal, say here and here, they're known as consecutive angles. Now, what's the significance of alternative versus consecutive angles? Well, when we know that angles are alternative to one another, then we can conclude that they are congruent. Because even though we're not directly comparing this angle to determine congruency, as the transversal cuts these two parallel lines at the same slant, we can conclude that all 4 of these angles are congruent to one another. So if we are looking at, say, this angle, I'll call it A, and this angle B, we can determine that they are the same. So alternate angles are congruent. And though looking at the position of angles just visually is not a way to go about things all the time, we can kind of tell that this angle is of a similar size compared to this angle. They are alternate. Now, consecutive angles. Consecutive angles are significant because they are supplementary, going back to this relationship here where 2 angles add together to equal 180 degrees. So these 2 angles that we identified earlier, if I called this one C and this one D, would be added together and it would equal 180. So if you were given one or the other, you could easily subtract to find the remaining angle. Now, just a couple more important things to know about determining relationships between angles are the areas of 2 parallel lines cut by a transversal. I'll go ahead and change the color here. So, as you can see, the 2 parallel lines create kind of an inner area. I'll shade this in green quickly. And an outer area. I'll circle it in green quickly. They kind of make sort of a sandwich with the interior area in between. This area is known as the exterior. And this area, the interior. So, if an angle we're focusing on falls within this area here, it'll be known as an interior angle. Whereas if an angle falls above that area, say here, it will be known as an exterior angle. So now we're able to combine the terms interior and exterior with the terms alternate and consecutive. So if we wanted to look at this angle here, I'll call it X, and this angle Y, in order to determine their relationship to one another, we'd first have to ask ourselves, well, are they in the interior of this collection of lines or on the exterior? They're on the exterior. Now, we're going to take another look to determine whether they are on the same side of the transversal or the opposite side. They are on the opposite side, making it a pair of alternate exterior angles. And as these angles are alternate, we are able to conclude that they are congruent. So, now that we've gone through a couple of the basic angle relationships, let's see if we can work through a problem where we are given, say, the measure of angle y and need to find a measure similar, not similar, but in the likeness of a, x, or b. Let's take a look. Now, in this practice, we are given a measure of 50 degrees in this exterior angle. And we're looking to find the measure of angle x, which is also exterior. So, we've determined that they are both exterior. Now, the next thing we're going to look at is whether the two angles in question are on the same side of the transversal or opposite sides. By taking a look here, we can conclude that they are both on the right side of the transversal, as they are on the outside of this middle portion here, and they are on the same side. We are able to conclude that they are consecutive exterior angles. And what have we learned about consecutive exterior angles? We learned that they are supplementary, which means they add to 180 degrees. So we're going to write that equation out now. X plus 50 degrees equals 180 degrees. Now, when we subtract 50 degrees, we are able to find that the measure of angle x is 130 degrees. Alright, that has been different angle relationships and a common way to apply those different relationships to determine the measure of an angle involved in a collection of two parallel lines and a transversal.